replacement fuses as I wanted. The problem now I found that this socket, the fuse that was inside here, it wasn't the plastic casing that was just missing. The plastic case, it was molten inside of there. And I have tried to remove the fuse, and there are the remains of it, so it was burning as well. So I think the smoke effect was not just from the coil that I thought it was from, but also from the burning fuse. I bet it was a higher amperage than 10 amps. That's why it was still intact while the plastic case was all burned up. Now I think I will have to go to the electronic shop again and find a replacement jack for this fuse, socket for this fuse. Let's see what kind of a socket this is. I'll unplug it and take it out. There are some plastic clips holding it in place. Okay, almost there. So maybe you can see inside there's lots of molded plastic, and I still couldn't take out the last piece of the fuse. So now I have a broken fuse and a broken fuse holder. I will have to replace this, or if I can't find a matching socket, I will have to think of some other way to mount this fuse onto the case. By the way, I also got myself a few load resistors from the electronic shop. These are cemented wire wound types. I couldn't find... okay, so I calculated that in order to have 6 amps flowing, I would have to get a 2 ohm resistor, but they didn't have any 2 ohm resistor in the high enough wattage, because there will be lots of current flowing. It will overheat if it's a low wattage type. So I got myself 20 watts, 10 ohms, 5 resistors, which in total, if I connect it in parallel, gives me 2 ohms and 100 watts. That should be sufficient enough to test this power supply when I get it running. So I went to the electronics shop again, and I got myself a new fuse holder. And they didn't have the exact type like this one, but they did have this type, and it has a cap with a fuse written on it, and there are the contacts. It is, well, quite a cheap one, and you can see it's rated for less amps than the first one. The terminals are smaller, and in general it's just not such a quality item. I can feel it's not so sturdy, and yeah, this seems to be a higher quality one, but this is the only one I could get locally, automotive fuse type panel mount holder. This is rated for 15 to 30 amps, and this one I think will be fine for 10 amps. We'll see. Let's see if it fits in the case. Yes, it does, and I may be able to even mount it with a few screws. If not, then I may have to drill a bigger hole, or drill a little notch on both sides of the case, here and here. The screws wouldn't mount properly, so I did end up doing a few notches. Here's one up and here's one down. And now I will try to mount the fuse holder and see if it fits. Here I have already mounted the fuse holder. It's not a perfect fit, but it holds quite well, and it's sturdy, and I think it will be fine. I found just the right screws and washers for this type of fuse holder. And here's the back side. Let's connect it, the fuse holder. Okay, here I have another problem. The connection is loose, so I will have to fix this as well. I have used my pliers and push this connector a little bit on the sides, so now it stays very well. Let's insert the fuse and change the 8 amp to 2 amp fuse. I actually got a 2.5 fast acting fuse. I think it will be perfect for this. I have replaced all of the fuses with the correct type ones. Here is a 10 amp automotive fuse, and here I put 2.5 amp fast acting fuse. This should be fine. Now what I'm going to do is connect all these 5-10 ohm resistors in parallel to give me a total of 2 ohms, and then I will test the 12 volts function, if it can deliver minimum 6 amps. If that is okay, we'll let it run for a while, see if no more smoke comes from this device, and then I may even briefly test the boost function and the 24 volts function, but because my resistors are not rated for this much power, I will just test it very briefly just to see if it works. I have turned on the device and I have connected one side of one electrode, the negative side, to one side of my resistor dummy load, and now I will connect the second one and see what happens. Ideally, since it's a 2 ohm load, and if it can deliver 12 volts, there should be around 6 amps flowing through it. So, after a few sparks, let's see what the meter is showing. 5, 6, 7 amps. That is a little bit too high, so let's check the voltage. I have connected my multimeter probes, and it's showing us 10.2 volts. So there is something not right with this ampermeter. I have turned on my multimeter and set it to amps, to measure amps, and I have selected the right input jacks for that. It should be able to pass 10 amps without blowing the fuse on the multimeter, so let's test it. I connected one side of the car battery charger to one side of my dummy load and another one to the multimeter, and let's see what happens when I connect them. 4.8 amps. And yeah, let's do this again and see if the reading on the car battery charger is still the same. Yep, it's showing still 7 amps, even though my multimeter is saying 4.8. So there's definitely something wrong with this ampermeter. Now my theory about what's wrong with this ampermeter, I think it's not the ampermeter itself, but rather this coil that the ampermeter is measuring the current flow through. And I think that due to overheating at some point, it changed its resistance value, and now it has a higher value than it was before. And now the ampermeter, which is essentially, I think, a millivolt meter, it's getting more voltage drop across this coil, and thus it registers more amps than there are actually flowing. Just out of curiosity, I have connected my Fluke temperature probe to the multimeter, and I want to measure how much heat it is the dummy load is generating when there is about 5 amps of current passing through it. So the ambient temperature is about 26 degrees Celsius. And the resistors may still be warm from my last attempt to power them. Let's check what's the temperature now. So it's rising steadily because the temperature probe itself has to warm up. So it's about 32 degrees. Now let's connect power to my resistors. It should be about, like from the last time we measured, it was about 5 amps, 4.8 or so. Some sparks. It's showing about 7 amps, so yeah, from my last experience, it's about 5 amps. And let's check the temperature and see how fast it rises and how much. So it's 32, 33, 4, 5, 8, 9, 10. So it's rising about 1 degree per second now. I will leave it for a few minutes and then come back and check it again. By the way, when I was connecting the new, putting in the new fuses and then connecting all the leads together, I accidentally shorted them and I blew one of the 10 amp fuses that I had. Luckily I bought 2 of them, so now there's the second one. Hopefully I will not short it out this time. I think what I'm going to do about this incorrect reading, which is showing about 7 amps for 4 and 4.8, and here it's showing 7.5 or so. I think I will clean the leads of this measuring resistor, unscrew everything and clean it up a little bit, maybe with a contact cleaner or with a Dremel or something. And then if that doesn't help, I may try to measure the resistance of it and maybe calculate how much it should be and maybe trim a little bit, like cut a few coils out of it or something like that. As last thing, it was running for a couple of more minutes. Let's check what's the temperature of my dummy load, just for fun. So it's risen past 90 degrees. Oh, it's cooking temperature, 110, 120, right, about 130, about 132 degrees. So I can cook on it already. And I have a cooking plate ready, so it smells like toast. And who needs a toaster if you have a car battery charger and a few resistors? Yummy! Now that both sides are cooked and crunchy, all I need is a little bit of peanut butter. Sure, yummy! There we go. So let's try resistor toasted bread with peanut butter. I just could not resist not finishing the whole piece of my bread and
So I hope you liked this video. For more information, click the link in the description.